Hopefully you're here to learn about migrating your data platform into the cloud. If you're not, you're in the wrong room. So basically where we start here, I talk to customers quite often, and I work for GridGain, and we have a data grid. And one of the questions I get quite often is, does it work in the cloud? And if so, how do I get there? And most of what I'm going to talk about today is based around these conversations and some of the advice I have to give to clients and the difficulties people have kind of moving from like on-prem to in cloud. So firstly, we're going to take a bit of a step back. We're going to define our terms, because the problem with cloud is it's kind of a bit of a vague term. It means different things to different people. So before we go too far down the road, I want to have us all on the same page about the kind of problems that we're trying to solve here. And secondly, what software are we trying to put into the cloud? So, if you're putting a web server in the cloud, that's one thing. If you're trying to put a distributed data platform into the cloud, that's a different problem. So again, I'm going to talk a little bit about what GridGain is and how it makes it different from some other platforms, other software you might put in the cloud. And together, once we've got those things defined, we can then start talking about the different deployment options you might have, and things you might consider, things that, much like anything we kind of talk about, there's no one right answer. It's a complicated problem, and some things, you might have some advantage on one thing, but that gives you a disadvantage somewhere else. So it's all a matter of figuring out what the trade-offs are. So when you leave here, you won't be able to kind of say there's one right answer for deploying things into the cloud, but hopefully you'll have some ideas, some thoughts on the things to consider should you do it. And then based on those options, we can talk about a few best practices, kind of some things to, again, maybe not one right answer, but things to consider when you're kind of moving there. So the first thing I want to talk about is what is GridGain? And again, what we're talking about here isn't necessarily specific to GridGain. Anything kind of similar kind of works. So GridGain is a distributed data platform. And what does that mean? Well, we store data and we kind of allow compute on it. And we can spread out that computation and all that data across the grid. We scale horizontally. And the data is spread around it. So any node might need to talk to any other node, and everything kind of interoperates in a way. So unlike, say, a web server, where it basically holds no state and you don't necessarily need to share information between them, in GridGain and Apache Ignite, which GridGain is based on, all the nodes need to talk to each other and kind of be relatively near each other. Just a few examples of the things that GridGain actually does. So distributed memory-centric storage. So you store this data in memory. We do co-located computing. So rather than kind of sucking the data from the grid, doing a computation and writing the answer back, we take the code and send that to the data, which makes the computations that much faster. We have multiple different ways of accessing the data in the grid. So we can use distributed key value stores. We can use SQL to access it. We have ACID transactions, and if you think about it, huge amounts of data, huge amounts of compute, machine learning, an obvious example, and we have our own algorithms built in that do that kind of thing as well. And you can kind of think of GridGain as being like a toolbox that allows you to use all these things together in one place. And it kind of looks like this in a way. So the important things to consider for our purposes here today is our clients at the top can access using almost any kind of technology. So we have, Java, .NET, C++, PHP, REST APIs, anything like your clients can kind of plug in and do that. You can access all the different features from the different clients. And in the back end, we have basically the cache is distributed across the entire cluster. But the way it works is you have a number of machines that make up your cluster. And each node may or may not have some storage space. So if we use GridGain as like a database, each node stores a little bit of your data, which means that Again, unlike a web server where you probably have a central store of your data or a copy of it there, in GridGain, each disk is kind of unique and kind of separate and needs to be kind of maintained separately. So that's kind of what makes GridGain a bit different from many other applications. It's distributed, it's spread out, it has lots of memory, lots of compute, and lots of disks. So it's actually quite a demanding application as well. Most of our clients typically deploy on-prem, but as I say, we're getting more interest in the cloud. So which brings us to our next question. So what is the cloud? Sometimes when you come across it, people just think it's a computer, but it's in someone else's data center. That's one way of looking at it. And the problem I found when kind of trying to research this and having spoken to many people over the years about this is there's no one definition of what the cloud is. It means slightly different things to different people. So you go to Salesforce's website, ask them what the cloud is. And they say it's flexible, allows disaster recovery, has automated software updates, because they seem to confuse cloud with software as a service. So when I talk about cloud today, I'm not really talking about software as a service. Capital expenditure free, so again, a nice business benefit. Increased collaboration, well, maybe if you're using Salesforce, but not generally just if you're using Amazon Cloud Services. Work from anywhere, well, who knows where your data center is. Document control security is an interesting one. We're going to talk about that in a bit more detail. And environmentally friendly, I guess unless you try and print out your terabyte of data, I don't know. So that's what Salesforce think, but I found a website called Lifewire, and they had a slightly different list. So they say it's cost efficient, unlimited storage, I guess if you're prepared to pay for it, backup and recovery, again, depends on your cloud provider. Software integration, ease of access, quick deployment. Quick deployment is kind of an important one. Many people use cloud services because it allows them to kind of iterate more quickly, but there's nothing inherent in cloud per se that allows you to do that. So again, we're going to come back to that in a little bit more detail to kind of, so the way you do that, it depends on some of the details you do to your deployment rather than cloud per se. Technical issues. I'm not quite sure what they mean by technical issues. Is that a good thing or a bad thing? Security again comes up, and prone to attack. So again, this is not really a big feature of cloud, but that's what they say. IBM have a different take, so I'm not going to go through all this full list. But there's some overlap, some not. But the point being, everyone has a different idea of what cloud actually means. So I'm going to tell you what I think cloud is, and that way you can kind of think that everything we're going to talk about after is based on what I think of it is. And you can argue with me after the talk if you like, but this is where I'm coming from when I talk about things the rest of the time. So I think one of the most important things about cloud is scalability. So if you have your software in your data center and you need more capacity, you go to the purchasing department and order a new machine, and Dell ship it in a couple of days' time. Then you got to talk to the infrastructure team, and they got to take it out of the box and put it in the thing. And it takes time to kind of set it up. But in the cloud, you can click a few buttons, get a few extra machines built out almost straight away with kind of no notice. And if you don't do that, if you just assume that you have 3 computers, but instead of in your data center, they're in the grid, in the cloud, you're really not taking full advantage of the cloud. So what we're trying to do in this presentation is we're going to try and figure out how we can use GridGain best by allowing to use scalability. And of course, there are other nice advantages of this as well. If you do that, is you can pay for what you use. So if during the day, you only need 4 computers to kind of deal with your load. But overnight, you have these massive batch jobs you can run. So during the day, you have 4 nodes, and overnight, you add another 10. So you can do your compute that much more quickly. Then you can shut them down in the morning when you don't need them, or vice versa. So kind of that elastic scalability, hence the photograph, is kind of a key point, I think, in the cloud. And also just, companies like Amazon, for example, their busy time of the year is like November, December of the year, so they can add more capacity at particular times of year. So again, It doesn't have to be just overnight burst capacity. It can be just relying on the capacity you have. So scalability is one factor. The next one I thought is flexibility. And what I mean by this is if you're building out your own data center, well, firstly, you may only have one data center. If you're a relatively small company, it doesn't make sense to build 10 data centers all around the world. If you're Amazon or Microsoft or IBM, it does. You can do that. So you, as a customer of these cloud services providers, can take into that flexibility and have your data duplicated around the world, either for resilience or to allow local users to have access to data that's closer to you. But other things come out of that as well. So, for example, maybe your workload is very specific, and maybe you could use GPUs to do the computation more quickly, or maybe you have some machines, some tasks that require huge numbers of CPUs, but some that require huge amounts of memory, for example. If you're doing that in your own data center, you might have to order off-book effectively to get your right hardware, because the standard is this particular size. But in the cloud, you can order anything you want in the configurations that are available. And also, the other thing this flexibility gives you is it allows you to upgrade the software more easily. So if you're doing it in your own data center, you probably have to upgrade the software on the box, or you're trying to upgrade to a new version of the operating system, a big upgrade. You might have to do it kind of in place. In the cloud, just fire up a new virtual machine with a new operating system, copy stuff over, shut down the old one, job done. So again, that flexibility is an important aspect. And the last of the three elements I wanted to talk about that I consider the important bits of the cloud is it's not in your data center. And I know that's kind of obvious, but there's a number of different side effects about this. So firstly, you don't need to manage your own data center, which goes back to the previous point. It gives you a huge amount of extra flexibility in what you can do, because Amazon and Microsoft have done all this kind of great work with those esoteric features that give you huge amounts of power that you wouldn't have otherwise. But the other side is the security. It's in someone else's data center. Can you make sure the data is secure? Can you make sure no one else gets in to access it? You have to be a little bit more worried about this. The other point, though, is all your other data is quite possibly in your data center, and you're putting GridGain or Ignite or what have you in the cloud. And now your cache is a long way away from your data. How do you get the data from one side to the other in an efficient manner? Do you need to move your kind of source database over into the cloud? Does GridGain become the new source of data? How does that work? So again, there's no one right answer here. I'm just kind of saying the fact that the data is elsewhere is something you need to consider when you're kind of deploying things. And if you take all these things together, so you take the scalability, you want to be able to kind of shut down and bring up new nodes very quickly. The flexibility, you want to be able to use new toys as they become available in the system. And you want to take into account the fact that, the data center's the other side of town. You don't want to download your software onto your laptop and then have to copy it laboriously to every new machine in your cluster. I think the first best practice I want to talk about is tooling. So when you control everything in your own data center, it becomes a bit easy to be kind of lazy, I find. You can SSH in and you copy files over, and you can kind of do it a bit kind of hacky. And I see many clients still doing that. But if you don't take the best advantage and use some of the more advanced tooling, you're really not going to get the best advantage of going to the cloud, because it's going to be much harder to fire up a new node. It's going to get harder to kind of shut down nodes and kind of replace them and upgrade and all that kind of good stuff we talked about earlier. So an important thing is to make sure you can kind of click a button and automate this as much as possible. And I'm not advocating any one particular solution here. I've seen clients doing everything. Maybe you got some shell scripts that SSH stuff over. That's kind of fine. Maybe you'd be better using something like Chef or Puppet or Ansible, though kind of nice open source tools that kind of can deploy things in a standardized manner in a configuration rather than code. All these are kind of nice advantages. Then you add a new node, you click a button, and Ansible just copies all the software you need over to the new machine, takes the configuration over, brings the new node up, and you're done. You don't need to do anything more than that. But in addition to that, it's like you've got your systems up and down and moved around and deployed, but there's no point in doing that if you don't know what's happening. So one of the important things that sometimes we take for granted when you're in your own data center because you have another team doing it is things like monitoring. So you need to be able to kind of put probes in and kind of see what's happening. Are you running out of memory? Is the disk space running low? Is the CPU load kind of getting out of hand? Because now, because you've got all this other tooling, you can deal with that. You can add new nodes. You can kind of deal with the scale in that way. But there's no point in being able to add new nodes to deal with load if you don't know you need to do that. So again, kind of monitoring is like kind of good. And different cloud providers offer different solutions to that. Some have some really nice tools you can use. You can automate stuff in that way. Some don't. There's lots of open source tools you can use to plug in to these data grids to kind of get nice rounded view of what's going on in your platform, both in terms of things like the Java virtual machine in the operating system, right through to your specific application and what it's kind of doing. I talked about Chef and Puppet and Ansible, but there's two kind of big tools that I didn't talk about yet, and I want to talk them a little bit more detail because we're going to need these as we go delve into some further detail later on. So the first is Kubernetes. One of these big things that it's a big name everyone seems to be talking about. I don't know about your experience, but I'm not seeing many people actually using it in production. Typically small to medium companies might be doing it, kind of startups, but kind of more established companies I'm still seeing people interested in but not using it. But what is it? Well, it's a way of effectively managing containerized applications. So you define what they call pods, and you kind of configuration, you define what your configuration looks like, and Kubernetes will create that structure for you. So it kind of deploys GridGain and your other tooling into the grid, and you can do clever things like auto scale, so you can add new nodes and remove nodes and things like that as the load varies, and you can do that in an automated manner. So yeah, an open source system for automating, deploying, scaling, and management of containerized applications. So I guess there's the second question that comes out of that is what's a containerized application? And typically that's Docker. So again, you can use Docker without using Kubernetes, and we see some deployments doing that. We see people manually kind of bringing up, manually maybe not the right word, but outside Kubernetes bringing up clusters using Docker. And Docker container is a standard unit of software that packages up code and all its dependencies. So again, this comes back to automating as much as possible. So keep your code, all your dependencies in one place. You can programmatically kind of do it. You can check it into source control, which means you can reliably add new nodes and know exactly the code that you're deploying onto the server. Because you don't want 3 nodes in your cluster having one set of software and some of the others the newer ones having different configuration. That's going to cause you a huge amount of grief. Using tooling like Docker, like Kubernetes, like Ansible is kind of essential in this kind of more dynamic and flexible environment. Because we can cheat. One way of managing environments like this is to kind of say, I don't want to do it. And GridGain does offer GridGain Cloud. And basically the way you do that is you go into the website, you kind of say, I want to have a GridGain cluster. It fires it up in the background. We do all the work. You don't need to worry about it. So it's fully managed. You can access the console. You can access the data using REST, JDBC, thin clients, up and running in minutes. That's all I'm really going to say about it. It's available. You can't really do compute on it yet. Our strategy on this is still kind of evolving. But I thought since we're talking about cloud, I should briefly mention this. So I'm assuming you're going to do it yourself. There are 2 or 3 obvious providers that you're going to hear about. So the first one is Amazon. They're basically everywhere. But the problem I find with Amazon is it gets very complicated very quickly. There's like a million options for everything, and they're all permutations, all kind of all over the place. So if you just want like a virtual machine, well, there's at least 3 kind of types. There's EC2, ECS, and EKS. They're all kind of based on EC2, but they offer different levels of abstraction on top of it. So EC2 is the basic virtual machine. They could have called it virtual machine, but they decided to make it more confusing and call it EC2. ECS is the container service. So you can deploy your containers that way into the cloud. And you can do things like scaling and all that kind of stuff automatically. That's kind of quite nice. But it uses Amazon's scaling system, not like a standard one. AKS is the same, but using Kubernetes. And your instances of your EC2 instances have different varieties. So there's like on-demand and spot. So you can kind of reserve something, or you can just kind of have it now. You can dedicated hosts. You can have fixed performance. You can have it burstable. You can have different configurations for networking. You can use Intel or ARM hardware. There's lots of different default configurations. So as a general purpose, compute, memory optimized, accelerated, storage optimized. Just huge number of different options. It's kind of difficult to know where you're coming from. I'm not going to leave it there. We'll come back to this. Azure is sort of similar. It actually has many, many options too. Their menu is a little bit simpler. They talk about virtual machines. They talk about virtual machine scale sets, which is like ECS on Amazon. They also have a Kubernetes service and container instances where you can deploy containers as well. We also, GridGain is also part of the Cloud Native Foundation. So, that's kind of way of saying we're serious about the way you can deploy in Kubernetes. And we use the same options to deploy in almost other places. So the obvious ones, Google Compute Cloud, we have options there. We have good documentation on doing that. Google Cloud is not quite as interesting, as many options directly as Azure and ECS, basically because you can dial in your own options. You don't say, I want option A, B, or C as you do in Amazon. You can kind of basically have a slider and say exactly how much memory you want and exactly how many CPUs, which is a lot more flexible, but a lot more confusing in many ways. We also support Oracle Cloud, and on-premise you can use any kind of cluster kind of software as well, so kind of Mesos, Yard, Zookeeper, VMware. OpenShift, it's the new Red Hat, IBM kind of system. And many customers, one of the advantages of something like Kubernetes, you can mix your environment as well. So rather than sticking with just Amazon, if you use Kubernetes, you can easily use pretty much the same configuration and spread that out both into your on-premise environment and into one or more cloud environments too. And you can basically use the same configuration in 2 different places. Again, it avoids kind of vendor lock-in, and we see quite a few people looking to do that as well. So kind of looping back to what we were talking about before and the gazillion options we saw, especially for Amazon, but the other options too. The best practice is around memory sizing. So GridGain is memory intensive. It's basically an in-memory database. So if we have some customers with petabytes of data and storing it in memory, or at least predominantly in memory, this is something you need lots of. So typically, what we see, if you look through the different vendor options, if you look for the big memory options, they're the ones that typically work out best. So we have something else to consider is resilience. So the way GridGain works is it can distribute the data around and have backups as well. So you can survive 1 or 2 nodes kind of going down and not lose any data. So we would typically kind of say, don't have one big node. Have 3 or 4 slightly smaller nodes where you can kind of duplicate some data between them to allow you to kind of survive failures. And finally, on the Ignite website, we have a sizing calculator. So you can enter the size of your data, how many records you have, for example, and it will kind of tell you the kind of configuration you need. And maybe using that, you can kind of go back and look into Amazon or whatever and figure out the best compromise. So just looking at my notes here, so in AWS, the ones I would typically recommend are like the 5R and 5RD, maybe the X1 and the Z1. So they're kind of pretty beefy configurations with a reasonable amount of CPUs. So again, depends exactly on your use case. You would need to kind of think about that and measure it and benchmark it to make sure that it was right. But they're kind of reasonably big without being ridiculous. So Amazon also offer they actually offer one called a high memory configuration, which has 6, 9, or 12 terabytes of memory in one virtual machine. But for the reasons I kind of mentioned about in the second bullet point there, I probably wouldn't recommend those. Kind of use one slightly more nodes with slightly less memory. So Azure, they have instances called E, so E32 and 64, and the G series have kind of reasonable amounts of memory you could use. Google, again, high memory types. Oracle, their VMs are not great. Their VMs typically don't have very much memory in them. But their bare metal options are pretty good. They're like a half terabyte memory in them. They're not bad options. So again, there's lots of different things. I'm not saying don't look at the other options, but this would be our general use case, a general recommendation for a fairly standard GridGain installation. GridGain also works as a database, so it can not only store things in memory, it can persist things to disk as well. So each of your nodes, if you have persistence, will probably want to have a disk in as well. Many of the same compromises we talked about in kind of terms of memory. Because we're predominantly an in-memory system, you want your disks to be as fast as possible. So pick SSDs in preference to spinning disks. Again, a nice trade-off. So some EC2 instances, for example, have disks attached, but they're not kind of clouded disks per se. So EBS is the cloud, Amazon Cloud Block data store. That allows you to do things like snapshots and that kind of stuff, which is kind of nice. But these SSDs in the standard instances are faster. So again, not a right answer or a wrong answer, just a trade-off to have. I think in most kind of high performance situations, I'd probably recommend the SSDs built in and use GridGain's snapshotting and backup rather than EBS, but something to be considered. Azure, again, don't use the spinning disks. They're kind of terrible for this kind of high performance in-memory application. You're spending all this money on an in-memory data grid, don't slow it down by shutting everything to a very slow spinning disk. I did a talk on this last year about using Kubernetes. If you're using persistent stores, use stateful sets if you're using Kubernetes, which basically means the disks come and go in a predictable order. How that works in the specific cloud provider varies, but broadly speaking, stateful sets is the Kubernetes option to do it. Even if you're not using persistence, of course, you're going to have things like logging and configuration options and all that kind of stuff. For that kind of thing, the performance matters a bit less. As we talked earlier about using tooling, you probably want to think about make a centralized source for logging, maybe kind of Elasticsearch or Splunk or something like that, rather than just kind of writing things out to log files locally. But again, you're going to need some local disk. And yeah, that's kind of less critical. So this comes back to the flexibility slide we were talking about earlier, one of the kind of key elements of using cloud. There's no point in theoretically being able to create new nodes on demand if every time you do it, you've got to start to spin up a new default instance and copy some files over and do all this kind of complicated stuff. So use custom images. You can do that on Amazon. I think you can do that on Azure and all the other providers. So kind of create a custom image that you can just kind of like press a button and spin up in one go. This also works with containerization. And I say it makes it easy to create and kill new nodes. It makes it easy to upgrade as well, because that way you can basically shut down your cluster, bring it back up again with a new version of software, whether that's GridGain, your application, operating systems, or what have you. It just means that Everything is consistent. You're running the same versions of software everywhere, and it means you know what you're doing and you can do it quickly. And that's the key here, I think. One of the things we talk about when you deploy to the cloud is often a shared resource. So you have a virtual machine, and you got another machine that another client on the same machine that you don't even know might be hogging half the CPU. So if what you're doing is just a batch process, that might not matter. But if the work you're doing is closer to real time, that might be a factor. So again, this is something you need to think about when you move from on-premise to in the cloud. And again, no one right answer. Things like Amazon and Azure have these options where you can kind of choose kind of the relative priorities. So if you reserve it, you say, I'm going to use this machine for the next 2 months, next year, you can kind of reserve it and kind of say, I'm going to have this amount of capacity, versus Spot, which is going to say, I want a new machine right now. And again, this comes back to, maybe your cluster is normally 4 machines in size, and you probably want to reserve that. But if you want to kind of have burst capacity and kind of use it for extra processing on demand, you could just kind of use those extra in kind of Spot. But again, this is something to think about when you're deploying it. The other side, and again, this comes back to tooling and automation. Something you can do quite easily in some cloud environments is kind of automatic scaling. So your environment's there, you've got clients hitting it, everything's happy, it's running along at, I don't know, 50% utilization, and everything's great. Then all of a sudden, something happens. Maybe when a node goes down, maybe a ton of new clients come along and start hitting it all at once. And you start heading to like 80, 90% CPU utilization, or your disk is running out. Using things like Kubernetes or some of the other cloud providers' kind of specific solutions, you can have it so it monitors the situation automatically and adds new nodes dynamically and removes them when you no longer need them. So again, this is something like peace of mind you can kind of run to kind of keep things running even when you're not there, without having to look at a dashboard application to figure things out. The last point's an important one though. So GridGain is typically sold. It's typically licensed in terms of a number of CPUs. So you've got to be a bit careful that you don't exceed your quota for a period of time. But again, this is something we're always happy to talk to you about. Just, again, an extra factor to consider. Best practice number 6, security. So as we mentioned at the start, it's great, but it's in someone else's data center. So can anyone else get in? Can you make sure that no one else is going? Is a disk encrypted? Because if you've got confidential information, you don't want it falling into the wrong hands. So Apache Ignite and GridGain has a number of different security features that you might want to consider, depending on, I say, the confidentiality of your information, security policy of your company, that kind of stuff. So we can have encryption between nodes. You can send information between them using TLS SSL encryption. That's pretty easy to set up. We also have on-disk encryption. That works kind of quite nicely. The other option, many cloud providers allow you to have encrypted disks as well. I would recommend pick one or the other, don't use both. GridGain itself also has a number of security options, so you can authenticate as you're going in. You can kind of restrict access once you're in. Allow every kind of client that connects to the system can kind of check to go in. And the other thing is auditing. So maybe you can't stop everyone getting in, maybe there's something going on, but you can at least audit it and kind of see who's doing what to make sure even authorized people are not doing naughty things. On the last one, the firewall ports, something we see quite often. Because GridGain is a cluster, because every node can effectively talk to every other node, we see some clients trying to limit access by closing up all the firewall ports. We see this often causing trouble because GridGain needs to talk to lots of other servers, and if you limit access like that, it can cause problems. It can be made to work, but you're probably better having the ports open within like a virtual network in the cloud that way. So yeah, security is kind of an important one. It's one of the things to start thinking about when you start architecting your application, before you start kind of rolling it out, because your security team are bound to have thoughts on this, and it's something that's quite hard to retrofit, the last week before you're supposed to go live. Data location. So again, one of the important elements of cloud is that it's not in your data center, it's somewhere else. And there's really no right answer for this. Depends on your application, depends on your business, depends on your use case. But yeah, just consider the fact that the data is separated quite considerably in terms of latency, in terms of bandwidth from potentially the rest of your data. So how do you get the data from one end to the other? Is it a batch job? Do you just send the changes over rather than the full information? I see quite a lot of times like a daily batch job that kind of takes the current set of data and copies it into GridGain. But that's if your data center is where your data is and GridGain's in the cloud, doing that every day might consume a huge amount of bandwidth, which is expensive and inefficient and kind of slow. Maybe the simplest solution, in technical terms, if not political terms, is to migrate everything into the cloud, which means all your data is kind of located locally. But again, there's no right answer to this. Just kind of remember that things are separated, and you need to kind of consider how to do that. And best practice 8, so the final one I want to talk about is, so let's say you've got GridGain running in your data center, and you want to put it into the cloud. How do you do that? How do you get information from A to B while minimizing downtime? Because I assume your application is actually in use and doing something interesting. You don't want to have to take the system offline for a day as your data copies all over. And the simplest solution we've thought of is to use the data center migration, data center replication feature. And you can kind of do it step by step in that way. So you have your on-premise data center. You bring up your data center in the cloud. So this is, you have your cluster in Amazon or what have you. You'd set up replication, and this way you do it like a one-way replication. So you send all your data to the cloud. In that way, everything in your on-premise environment would just keep working as before, but the data would migrate over gradually, including any changes. That at a certain point, it's finished, and you can see in the web console all the information has been migrated over. And at that point, you can shut off your on-premise installation, or alternatively, you can set up replication both ways and have both on-premise and on the cloud. The other thing worth noticing is we have some clients who have this kind of multi-cloud strategy, so you can have basically as many replicated data centers as you like. So you might have on-prem, Amazon, and Azure. I know some people who are at least planning to do that. And the replication works no matter, I think the limit's like 32 data centers. I don't know anyone who has 32 data centers and replicates between them, but I think that's the technology. So that's a pretty simple way of actually getting the migration going. And again, if you kind of follow the previous best practices, setting up a second data center like that should be pretty easy. So you got your tooling, so you kind of you can create new nodes pretty easily. You can use Ansible or Docker or Kubernetes to kind of do that. You can create this new environment in the cloud and set everything over. You can have a shared configuration, kind of sending information between the two bidirectionally in this case. But all of this would only be possible because of all the other steps we've followed, kind of automation and monitoring and all that kind of stuff. So what have we learned? Well, the cloud isn't special in many ways. In many ways, it is just somebody else's computer in someone else's data center. But it gives you lots of flexibility that if you don't take advantage of, you're really not going to take any advantage of the cloud at all. There's kind of no point in migrating. You'll save some money by not having to maintain your own data center, but you're not going to get the full advantage. You're not going to, you can't scale or recover from failure or, multiple data centers, all that kind of stuff. It's kind of missing the point, I would say. But the best practices, I would say, is kind of tooling. Automate as much as possible. Memory sizing. Go for the big memory options in general, but not too big. You want to have some degree of resilience too, so you can survive failures usually. Disk storage, so again, if you're persisting to disk, use fast disks. Use them. The disk should be as close to the nodes as possible. Unlike like an Oracle or whatever, you don't have all your data persist in one big SAN at the center of all your nodes. Each node has its own disk. So again, each disk should be fast. Use custom images. Again, this comes down to automation and tooling to a certain extent. But if you use custom images, you can bring up new nodes very quickly. And you can shut them down and upgrade and all that kind of good stuff. And performance. So again, you may not be the only person on that machine. And just take that into account when you're dealing with things like real-time workloads where you need much more precise control over what's going on. Security. So you're in someone else's data center. Make sure no one else can kind of get in or access the data where they shouldn't, and make sure you've got the auditing switched on, so if someone does get in, you can see what goes on. I mean, obviously that shouldn't happen, but you need to be prepared for it. You need to be prepared to answer those questions from your security teams. And data location. Data, your prime data source might be a long way away in network terms from your cluster, so you need to consider that and how to get the data between the two. And finally, migration. We discussed an easy way using data center replication to move the data from A to B. So that was kind of all I had to say. Thank you for coming. I hope that was useful. You have a question? Yep.
In your best practices, you didn't mention anything about how nodes communicate between each other. So if I have a large cluster on the cloud, if they are scattered all over the data center, so wouldn't that cause latency between communication between the nodes and hence degrading it?
Yes. There are a number of different ways of solving that, and there's not like a one-size-fits-all answer. So typically in GridGain, your nodes should be roughly the same network distance from each other. And so you'd have all your nodes in the same, like Amazon region, for example. And if you wanted to go to a different one, you'd use probably data center replication to copy between them. There are other options. So we have like a network segmentation, which basically means it has an increased awareness of some links not being as reliable as others. But in general, you're right. You need to minimize that kind of latency between nodes. And we have a number of different ways we can work around that. But that's a longer discussion, I think, is the short version. And if you want to talk about that later, I'm happy to do so. I mean, the cloud providers would typically have some options that you might not have locally. So if you use EBS storage, for example, on Amazon, they can do snapshots and backups natively there. The flip side of that is that if you do a snapshot of a live cluster, you're going to get an inconsistent snapshot because you've got to do it at the same time across every node. So in general, I would say you should be using the GridGain snapshotting tool, which is aware of the cluster. But in terms of resilience, you're kind of mostly using GridGain facilities, I would say. So GridGain, you can distribute the data across the cluster with backups, so it can survive. If you have like one backup of your data, that means you can survive one node going down. It comes down to your preference, basically. It's like how willing, because duplicating the data obviously is a cost associated with that, but losing the data, there's a cost associated with that. You've got to make that kind of trade-off, and in that sense, it's not specific to the cloud. It's just specific to the way you architect your application. Yeah.
The licensing is cool. If you've got hyperthreading enabled, does it count towards your core count?
I think it does, but it comes down to kind of commercials ultimately in the end. We use what we call compute units, which is I think 4 CPUs. If your servers have hyperthreading enabled, just mention that when we're talking, and we'll kind of factor that in, because obviously that's not a hyperthreaded CPU is not the same as 2 CPUs, but it's not not one CPU either. So, you know, we'll,
If the distributed system that you're moving to cloud, because its protocol has to use node ports, so each instance has a new node port, how would you recommend managing the firewall for that?
you know, in a Kubernetes environment. Or,
Yeah.
I guess if you're migrating over, you probably have 2 clusters, and each cluster would have its own node port, and you replicate between them that way rather
So
than.
if it was something where in a cluster, each of the nodes would have their own distinct node port, and then you scaled up, so you had some more, presumably you're going to have to go and adjust your firewall to say, now you can talk through these ones as well. So is that just going to be a manual process every time?
I would hope you'd be able to automate that, but I mean, again, this comes down to the particular cloud provider you're using, and there's, yeah, you need to factor that in when you scale, which is all the more reason you need to automate it so you don't forget, because, yeah, I've definitely seen situations where people kind of do things like that and wonder why the new server's not getting used or stuff like that. But yeah, no magic, unfortunately, but.
Yeah, it just seems difficult if the application inside was managing like auto scaling, and then obviously the firewall is an entity outside that cluster.
Yeah, I mean, this is kind of one of the reasons we don't ship with default configurations for Kubernetes, because the environment outside it, has many effects on what goes on. As you said, that's the firewall is one, but there's other kind of situations where, what's the maximum size you can scale to? You kind of needs to. Okay, well, I'm here for the rest of the day. If you've got any other questions, feel free to say hello. And thank you for coming.